Okay, everyone, this is section 6.3. Here, our goal is to be able to perform operations with functions. Some operations with functions, we have that any two functions f and g can be any functions where we can do any of the four operations with them. We can add, subtract, multiply, and divide with them. So let's say our first function we're going to call as f, and our second function we're going to call as g, and we name them up above there. But say we want to add them together to make a new function h. Well, all we're going to do is write f down and add function g to it, which is x plus 2. So we make a new function h. All we're doing is adding our like terms together. So 5x plus 1 more x makes 6x. And then we only have one constant of 2. So our new function h is 6x plus 2. But say we want to subtract them now. So we'll do function f first. And we're subtracting x plus 2, which is our function g. And notice I'm putting it in parentheses because we need to subtract the whole kind of function of g, okay? So if I make my new function h, I'm going to do 5x minus x, which is 4x. Then, if I distribute that negative to my constant of 2, it's going to be negative 2. So here's my new function h when I subtract f and g. And again, we had to distribute that negative to both of the terms on the inside of the parentheses. Now let's see if we want to multiply them. Well, starting with function f, I'm going to multiply that by g, which is x plus 2. So in order to make a new function h, I'm going to multiply 5x by both of the terms on the inside of the parentheses. So we're going to multiply or distribute again 5x to both of those. So 5x times x, well, that's 5x squared. And 5x times 2, that's 10x. So here's our new function h when we multiplied f and g. Now let's say, well, what if we want to divide f and g? Well, I'm going to start with 5x on top because f needs to be on top. And then g needs to be in the bottom, or x plus 2. And I can't really do anything else to it. So here's my new function h. It really can't be simplified really much more. So here's a new function h, 5x over x plus 2. So vocab here, a power function is a function of the form y equals ax to the bth power, where a is a real number and b is some rational number, or exponent. So let's use some power functions as our functions f and g that we're going to operate with. Okay, so let's see, we want to do add f and g first. Well, f is 4x to the 1/2, and I'm going to add to it negative 9 x to the 1/2, okay? And I'm putting it in parentheses because it's negative. So these are like terms that both have a variable with the same kind of exponent, so I'm not going to do anything to the exponent. I'm just going to carry it over, but I'm going to add the coefficients. So 4 and negative 9 make negative 5x, and we're keeping the exponent the same. So it's going to be negative 5x to the 1/2. Now if I subtract them, I'm doing the same thing. Here's f, and here's function g. Okay, now if I subtract these, 4 minus negative 9, I get that keep, change kind of going on. So it's like saying 4 plus 9, which is 13x to the 1/2. And again, we're leaving the exponent alone. It's just like terms, okay? Then part C says, well, the domains of f plus g and f minus g. If you think back what the heck the domain means, that just means what kind of x values can I plug into my f plus g and my f minus g, or what x values can I plug into our resulting function that we got when we added f and g and subtracted f and g. So looking at both of these, f plus g and f minus g, if you notice, if we try to plug in, let's say, negative x values in for x into both of these, well, it's going to give you an error in the calculator. So that means you can't plug any negative x values into there. Well, let's see if we plug in 0. Well, negative 5 times 0 to the 1/2, that still gets you 0. Same thing with 13 times 0 to the 1/2, that's just 0. So I can plug in 0. What about any positive numbers like 13 or 2? Okay, if you plug any of those positive x values in, you're going to get normal y values back out. So what this says is, for f plus g and functions f minus g, the domain, or what we could plug in for the x values, is only restricted to all non-negative real numbers. So any real number that is 0, or can be 0, or it can be positive, that's the meaning of non-negative here. Okay, so I'm not just going to say positive real numbers, because that doesn't include 0. 0 is neither positive or negative. So I got to say non-negative real numbers to include 0 and all the positive numbers. Okay. In example 2 here, we're going to see with new functions f and g, can we multiply them and divide them? Okay, so new functions, 6x for f and x to the 3/4, a power function for g. Okay, so if I multiply these two, 6x times x to the 3/4. Okay, if we multiply the big number coefficients out front, I got 6 times 1, which is 6. And since we have two of the same bases, they're just x. I'm going to add their exponents. Okay, but notice on the first x, I don't see any exponent. So remember to assume it's a 1. And I'm adding 1 and 3/4. So you could think about 1 using the same denominator as 3/4. 1 is the same thing as 4/4. Plus 3/4, that's 7/4. So we have 6x to the 7/4. Now let's see if we divide f and g. Okay, so f was 6x and g was x to the 3/4. Okay, again we're going to divide this time the big number coefficients out front. And remember, x to the 3/4 has a coefficient of 1 that you just can't see. So we're doing 6 divided by 1. Well, it's just 6. And then again, we're going to subtract the exponents this time instead of add. Okay, but remember on top of that x, you have an exponent of 1. You just can't see it. And we said before, well, that's 4/4. So we're doing 4/4 subtracted 3/4 this time. So we get 1/4. So it'd be 6x to the 1/4 for this one. Okay, so again, we're going to think about the domain, which we said was what kind of x values can we plug into f times g and f divided by g. So functions f times g and functions f divided by g. Okay, so what kind of x values can we plug in the resulting answers that we got up here for f times g and f divided by g? Well, let's start by looking at f times g, or resulting answer or function 6x to the 7/4. Well, if I plug any negative numbers in there, I'm going to get an error in my calculator. If I plug in 0, I'm going to get back 0 out. And if I plug in any positive numbers, I'm still going to get some kind of positive number. Okay, so for the domain of f times g, again, that's just all non-negative real numbers. And again, non-negative meaning I can plug in 0 and I can plug in positive numbers, but I can't plug in any negative numbers. And now let's think about f over g, or f divided by g. Well, let's see. If we're plugging it into our resulting function here, 6x to the 1/4, if I plug in any negative number, that's going to give me a big old error. Okay, and if I plug in 0, well, look back over here. These mean the same exact thing because they're equal to one another. If I plug in 0 when it's in the bottom like that, any 0 to the 3/4 power or 0 to any kind of power is still itself. So I can run into the jeopardy of 6 over 0. Okay, 6 out of 0 or anything out of 0, that's undefined. So I could run into that case, which is bad. 6 divided by 0, that's an error in my calculator. So I can't have any negatives. I can't have any zeros. What if any positives? If I plug in any positives like 2 or an x value of 9, I'm going to get back another positive number. So the positive numbers are okay. So for my domain or x values that I could plug into my f divided by g function, I can only plug in all the positives. So all positive real numbers, or all positive real x values for that one. I can't have 0, and I can't have any negatives for that one. So anytime you're asked for a domain, make sure to go through, can you plug in any negatives? Can you plug in 0? Can you plug in any positives? Little last piece of vocabulary here, we have the composition of functions. The composition of a function g with a function f is h of x equals g of f of x. And we say this as g of f of x. So basically we're taking one function and plugging it into the other one for its x values. So in this case, I would take function f and I would plug it into function g for its x value. Okay, so in this first one here, what we're going to do is think about, well, if I have two new functions, f and g, this tells me I need g of f of 3. And this looks weird, really weird because there's no x value. But what this does tell me is I'm going to take 3 and first plug it in the f and see what I get. So let's do that. F of 3. So I'm plugging 3 into my f's function. So I get 2 times 3, which is 6, minus 7, which is negative 1. So I got negative 1 now. And now I'm going to take that and plug it into g. So g of negative 1. Okay, so g of negative 1 now, well, here's my g function. I'm putting it in parentheses because it's negative. And I'm have to adding 4. So negative 1 squared is 1 plus 4, which is 5. And 5 is going to be my overall answer because I ran out of stuff to plug 5 back into. Okay, g was my last function I needed to plug it into. So 5 is my answer here. Okay, in the last example here, I have that two new functions f and g, and I'm going to compose them. We're going to put one inside the other one and vice versa. So in A, what I'm going to do is plug g, function g, into f. So I'm going to plug function g into function f's x value. So function f starts out with a 4, and instead of x, I'm filling it in with function g. But I can't forget the little exponent of negative 1 that was on that x in function f. So what I'm going to do is basically this negative 1 of an exponent tells me I need to flip the whole set of parentheses to the bottom. Okay, that was according to our exponent rules. Any negative exponent basically flips to the bottom and turns positive. So I'm going to leave the positive 4 on top. I didn't do anything to it. And I'm flipping 5x minus 2 to the bottom. I'm not changing any signs. I'm not doing anything like that. And from there, I really don't have anything else I can simplify with. So here is our new function. Okay, that was f of g of x. We plugged g into f. B says, okay, now take f and plug it in the g. So g starts out with f5. And instead of the x value, I'm taking function f and plugging it in. And making sure, don't forget to subtract that 2. It was part of function g. Okay? And now we're going to multiply. Well, 5 times 4, that's just 20. And we had an x to the negative 1 power minus 2. And we're not quite done because we have that negative exponent. We just said, well, negative exponents, they flip over. Okay? So it's not going to flip over with the 20. We didn't do anything to the 20. It's separate. But we're only going to flip the x down there because it was only on the x. If it were on the 20, we would need the parentheses around the 20 and the x. And then we didn't do anything to that minus 2, so it's going on the outside here. So here we have 20 over x minus 2. And the last one here, we're going to take f and plug it into itself. So starting out with a 4, and we're plugging f into itself again. And don't forget it's all raised to that negative 1 still. Okay, so now we're going to take that negative 1 again and distribute it to both of the terms on the inside. Okay, well, we didn't quite do anything to that outside 4 yet. And when we distribute that negative 1 to the 4, that's going to be 4 to the negative 1. Think about, well, this coefficient of 4 had a 1 already as an exponent. So 1 times negative 1 when we multiply or distribute there is negative 1. Then on the x, negative 1 times negative 1 is positive 1. Okay? Then, if we say we got rid of these parentheses a second and instead filled them in with dots, like we're used to seeing. Okay? Well, on this first 4, I have an exponent of 1. We just can't see it. Okay? And we're multiplying by another base of 4 raised to the negative 1. This is like saying x to the 1 times x to the negative 1. We're used to seeing them like that. They had both of the same base, so all I'm going to do is add their exponents. So 1 plus negative 1, that's 0. So 4 to the 0 times x. Well, anything times or to the exponent of 0 is 1. So that's just 1 times x, which is just x. So again, this whole thing, 4 to the 0 or anything to the 0, evaluates the 1. So 1 times x is literally just x. So x is our answer on part C there. So anytime you're composing, you're just filling in what you're given into the x value for the other function, or putting one inside of the other.